Okay, this video is about simplifying radicals, and also we're going to look at the distance and the midpoint formulas. So right here, if we're going to simplify some radicals, we have this situation. Let me just write down a few examples. There's a bunch on the sheet, but let me just pick a few to make sure that we're good at this. What if we have something like, let's look at the cube root. I don't want to do this one. Let's do the square root of y squared z over 36, okay? And then let's look at negative the cube root of 64a over b to the ninth. And then let's look at something like the cube root of 40 times y to the 10th. Then let's look at something like the cube root of y to the 5th. And how about the fourth root of 162 x to the 7th, y to the 20th, okay? And then maybe something like this, the square root of 45 over the square root of 9, or the cube root, let's see, or maybe the square root of a to the 7th, b to the 6th, over the square root of a cubed b squared. So here's something I just want to make sure you guys know. If you have the nth root of a divided by the nth root of b, this is equivalent to the nth root of a divided by b. Or, so if you have a quotient, you can write it as one radical. If you have the nth root of a times the nth root of b, you can write this as the product of the nth root of a times b under one radical. So this is a quotient rule and product rule that you can apply if you need to. So right here, I'm going to use that. I'm going to split this up. I'm going to think of this as the square root of y squared z over the square root of 36. The square root of 36 is just 6. So that part's done. And what I'm going to do here is that little division rule. I'm going to say the index is 2. 2 goes into 2 once. So one y comes out. There was no remainder, so no y's remain in, times the square root of z. Right here, the cube root. Let's look at this. The cube root of 64, so this is negative, is out there. And I'm going to think of this as the cube root of 64. How many times does 3 go? What's the cube root of 64? You can pull out a 4. How many times can 3 go into this a is raised to the first power? How many times can 3 go into 1? It cannot. So that poor little a has to stay right there. This times the cube root of a. But downstairs here, how many times can 3 go into the power 9? 3 times. So that means 3 b's are coming out, but they're in the denominator. So this is going to be over b to the third. So that's how that one can simplify. Right here, what's the cube root of 40? It doesn't go in evenly, so we got a little work to do. So let's think about this. What is in a 40? Is there a number that you can take the cube root of that is a factor of 40? And there is. 8 is a perfect cube. The cube root of 8 is 2. And 8 is a factor of 40. So I'm going to rewrite 40 as 8 times 5. That's 40. And then I'm going to deal with this y to the 10th. Okay. The cube root of 8 is 2. So a 2 is coming out right here. That took care of the 8. 5, there's not enough of factors in here to pull anything out. So what's going to be left over inside the radical is going to be the cube root of 5. Okay. And then for the power, for the variable to a power, we can do the division. 3 goes into 10. So I'll write this one out. 3 divides into 10. How many times can 3 go into 10? It can go in 3 times. Okay, so 3 can come in. 3 times 3 is 9. And I have a remainder of 1. The r, the remainder, that's how many y's remain inside the radical. So 1 y remains inside the radical. 3 y's come out, so this is going to be y to the third. And so this is the simplified version of that one. Right here, 3 can go into 5 one time, 1 y's coming out, but it had a remainder of 2. That is this simplified version. Down here, 162. Wow, I am not familiar with 162, so I need to start breaking it down. This is what I'll do when I don't know how to break something down. I'll take 162 and I'll start dividing it. 2 can go into that. 2 can go into 162 81 times. Now, if I spot that 81 is a fourth root, the fourth root of 81 is 3, then I'm in business. If I don't, then I just start dividing it. This is 9 times 9. This is 3 times 3. This is 3 times 3. And I say, oh, I can get 4 3s out of that guy, and this index is 4. That means 1 3 will come out. I can think of it that way. So let's continue with this one. This is going to be the fourth root of 81 times 2, x to the 7th, y to the 20th. All right. What's the fourth root of 81? It's 3. 3's coming out. What about this 2? You got to stay. So here's my leftover pile, the fourth root of 2. How many times can 4 go into 7? 4 goes into 7 one time. 1 x is coming out. What was the remainder? 3. 3 x's have to stay in there. 4 goes into 20 5 times. 5 y's are coming out. And the remainder was 0, so there's no more y's in there. This is going to be the simplified form for that one. So this is this one. This is a separate problem. This was this one. That was that one. Okay, now I have these two right here I wanted to talk about real quick. You can also go the opposite direction. So let me erase some of the stuff here. If I've got the square root of 45 over 9, the square root of 45 over the square root of 9. This might be an easier way. If I want to write this as the square root of 45 divided by 9, 9 will go into 45 5 times. So this is really the square root of 5. You can back it up that way. You can say 9 goes into 45 5 times. How about this guy? Let's look at this. If we got the square root of a to the 7th, b to the 6th, over the square root of a to the 3rd, b squared. You can rewrite that as the one big square root of a7, b6 over a3, b2. We can simplify under the radical using exponent rules. This is the square root of 3 will go into 7. I can wipe out 3 of these a's, and this will just be a to the 4th. I can wipe out 2 of those b's, and this will be b to the 4th. And then you can just say, okay, the index is 2. 2 goes into the power 4 2 times, no remainder. 2 goes into the power 4 2 times, no remainder. So that is simplifying radicals. Over here, let's look at the distance and midpoint formula. The distance formula finds the distance between 2 points, x1, y1, and x2, y2. So how far are those 2 points apart? It's given by d, which is equal to the square root of x2 minus x1, the difference of the x coordinates squared, plus y2 minus y1, the difference of the y coordinates squared. Okay. Then there's a midpoint formula. The midpoint formula is separate from the distance formula. This says how far apart, what's the middle of those 2 points. So it is literally, the middle is literally the averaging of the x coordinates. See, x1 plus x2 divided by 2. If you had 2 tests and you wanted to know your average, you would add those 2 tests together and divide by 2. We have just averaged the x coordinates and averaged the y coordinates. So let's just pick something off your sheet. How about number, here's one. Let's find the distance. Find the distance between the points -3, 2 and 1, -3. And so on your sheet, I think it's number 79. Okay, so we want to find the distance. This would be my first point. I just can label one point and the other point, and really it doesn't matter which order I decide to label these in. Just if you want to label them, that's a good way to go. To find the distance between D is going to be equal to the square root of x2 minus x1, or 1 minus negative 3 squared, plus y2 negative 3 minus y1 2 squared. All right. So D is equal to the square root. 1 minus negative 3 is 1 plus 3. Negative 3 plus negative 2 is negative 5. This is going to be 4 squared, or 16, plus 25. Negative 5 times negative 5 is 25. This is going to be the square root of 41. That's the distance between these 2 points. Now, what about the midpoint? I'll choose a different point because sometimes people get this confused, so I'm going to choose a different point to find the midpoint. What if I have to find the midpoint separate? Find the midpoint between, let's see, how about this? 2, negative 1, negative 2, negative 1, and negative 8, 6. All right. Remember, the midpoint is literally an averaging. So before we do this, let's just get some kind of idea of this. This is a quick sketch. Let's see, negative 8, 6. Maybe this is negative 8, maybe this is up 6. Negative 8, 6 is that point. Negative 2, negative 1. Negative 2, negative 1, maybe here. Negative 2, negative 1. So if this is a line segment in between these 2 points, what we're trying to find is the point halfway between that. All right, midpoint, you just average. It's going to be a point, an x-coordinate and a y-coordinate. You take negative 2 plus negative 8, negative 2 plus negative 8, divide it by 2. Over here, negative 1 plus 6, negative 1 plus 6, divided by 2. All right, negative 2 plus negative 8 is negative 10, divided by 2 is a negative 5. Negative 1 plus 6 is 5 over 2. So we're saying at the point negative 5, 2.5, that's where the midpoint would be. Let's see, here's where it looks like the midpoint of that line segment is. That looks like that could be at negative 5, 2.5. So that looks reasonable. All right, that is midpoint formula, distance formula, and some simplifying of radicals.